Hello everybody, I'm Michele Beccaria, a PhD candidate from Politecnico di Torino, and with this video I want to show you the key results about my research topic that deals with the design of innovative reflector arrays and transmitter arrays. Here there is the outline of the presentation, in which I will introduce myself, I will give you some introduction and motivation of the work, and then among all the topics that I investigated during my PhD program, we will focus our attention on the analysis and design of beam scanning reflector arrays for direct-to-home application. Then I will conclude the presentation with some final remarks and the future work. I started to study electronic engineering since the bachelor degree at Politecnico di Torino, until the PhD program finished the last July, in which I was involved in the analysis and design of reflector array and transmitter array antennas. During these 3 years, I was a research assistant at Tsinghua University in Beijing. Here, a brief resuming of the goals achieved in my PhD career, and all the results of the research activity are collected in 1 journal paper, 2 book chapters, 29 conference proceedings, and 1 pending patent. As already said, the main target of the research activity during the PhD period was to realize antennas that can work with the satellite communication, radar systems, SATCOM on the move, and the next generation of communication systems, or the well-known 5G. How can we satisfy all these applications? We want to have broadband antennas with the scanning and multi-beam capabilities, working from microwave to millimeter wave frequencies, and these antennas have to have a reduced volume and a reduced visual impact. So here what we do is to introduce innovative antennas based on the principle of passive reflector arrays and transmitter arrays. Among all the different design of reflector array, I show you here the beam scanning reflector arrays for direct-to-home application under the research contract of the Eutelsat company. The idea here is to connect the satellite and the reflector array antenna with these mounted on the wall of the building. The reflector array should direct its beam for different regions, from the region 1 to the region 3, from 10 degrees to 55 degrees. How can we do that? We can set the antenna in azimuth and elevation with different adjustment of the feed, of the illuminating feed horn, with the resulting reflective surface of this one. The manufactured reflector array is shown here with some particular radiating elements with very good radiation features and with the scan capabilities just moving the feed. What is mandatory to say here is that if we want a reflector array that covers all the angular region that I've shown in the previous slide, we cannot design that with a classical approach, but what has been done here is to design the reflective surface with a very sophisticated approach that is the quasi-spherical reflector array. In this way, just moving the feed, we can cover almost all the region that we want. Here, the key results about the measured normalized radiation patterns of the realized antenna are shown. In particular, for both the E and H plane, what we can observe from the lower frequency to the upper one, there is a very good stability of the main beam. In these 2 plots, the gain versus frequency and the beam stability are shown. In particular, what we can underline is the very smooth curve of the gain versus the frequency and the concentrated points of the direction of maximum radiation of each position of the feed, and consequently of the direction of maximum radiation. For the future, what we have thought is to design different kind of unit cell in order to improve the radiation performances of the reflector array, for example, the gain or the beam stability, and to design the reflective surface with a new optimization evolutionary algorithm in order to improve all the radiation performances of the reflector array antennas. Thank you for the attention.